The Masonic Medical Research Institute has been working on cardiovascular disease for decades. Part of its research efforts led to the development of the pacemaker as well as the internal and external defibrillators. In addition, we have helped resolve some of the pharmaceuticals and therapeutics that are being currently used to treat patients that have heart failure and hypertrophic cardiomyopathies. So our laboratory focuses on molecular biology and molecular signaling. We're very interested in understanding what causes heart disease and if there are genetic abnormalities that can lead to those disorders. In particular, we study pediatrics in children who have congenital heart defects that are associated with a class of diseases termed RASopathies.
So my research focuses on heart health, and what we're really interested in is understanding how the muscle of the heart communicates to blood vessels the need for more oxygen. So for example, when you get out of bed in the morning and your heart rate is rather low, and then you climb a flight of stairs and your heart rate obviously goes up, there's a need for more oxygen through the blood supply, and there's this intercellular communication that happens to lead to this increase in blood flow. And when that doesn't work correctly, that can initiate or exacerbate disease. So primary focus of ours is understanding the regulation of myocardial perfusion, and really we're focused at the interface of metabolism, and in particular intermediary metabolism, and how that regulates electrical signals in the vasculature to promote increases in blood flow, and trying to understand that in health and disease states.
My cardiovascular research focuses on a number of different areas, including heart attack and issues with clotting, including deep vein thrombosis and pulmonary embolism. I work with a lot of collaborators both internally and externally to develop both molecular imaging agents and drug delivery vehicles to treat all of these cardiovascular diseases.
The Kessinger Lab focuses on cardiovascular research questions like pulmonary embolism and deep vein thrombosis and how inflammation affects those things. We use innovative techniques such as molecular imaging, intravital microscopy, and in vivo translational imaging techniques such as micro-CT, ultrasound, and in vivo whole body fluorescence. In collaboration with Jason McCarthy, we use some of his innovative targeting agents, molecular imaging agents for short, and we look at inflammatory processes with those.
Everything is connected, so instead of just studying one gene that is involved in the genetic heart disease, so we are studying multiple genes that's unique but somewhat connected to study how they cooperate to promote heart development and function.
So our cardiovascular research, we do two things. One is to regenerate the heart. The other is to reduce the injury when the heart have a heart attack.
Cardiovascular disease affects 1 in 3 individuals in our lifetimes. It also kills 500,000 people every single year. It remains the #1 cause of death despite all of the advances that we have made to try to resolve this very devastating illness. The issues now are becoming more important because they're targeting our children. Obesity and diabetes are also going to end up causing cardiovascular disease in individuals, and that will eventually lead to a devastating number of people that will develop cardiovascular disease in the future. We've been solving this various family of disorders for the last 20 years and are proud to say that we're very close to coming to therapeutics that can help these families in dealing with some of the devastating cardiovascular effects that they have.